Hey guys, welcome back. It's Final Exam Guy, and today I got another special treat for you. We're going to be going through a calculus final exam. We're actually going to go through two final exams, so stay tuned for the next one. The first one is mediocre. It's a typical exam, but not if you're going to Harvard. If you're going to Harvard, forget about it. You're going to get like, what's the limit of x approaching infinity of ln ln whatever, all that complicated stuff. But no, this is your average typical final exam. The second one is a tad harder. Must be from a different professor, and he made it like really hard because he put ln's and exponentials. But so we're going to be going to both just in case. I assume that you guys have the foundation of calculus. You've done, you've read all the chapters, you've understood the concepts somewhat. You just need an extra little kick over here with this final exam. How I'm going to do it is we're going to go through each problem. We're going to find out all the tricks, what to look out for, and how we're going to solve these problems. So without further ado, let's get it on. So question one is a typical exam question. It's asking you to evaluate several limits as x approaches infinity, 0, and a real value. So the first one is the limit as x approaches limit as x approaches 3 of root 2x plus 3 minus 3 over x minus 3. So the first thing we're going to do in these types of problems is you're going to actually plug in the value you're evaluating at. So as x approaches 3, we're going to plug that 3 into the equation and see what we get. So I'm going to save time here. I'm not going to drop the limits, and we're just going to plug in our 3 plus 3 minus 3, all that over x minus 3. Sorry, 3 minus 3. Evaluating the numerator, you get 0, and the denominator 0. Alright, so you might be tempted to say that we have an answer here and it doesn't exist, because the question says write d and e when the limit doesn't exist. It's trying to pretty much trick you here. Some of you might write d and e over here and say the problem is finished, we're moving on. No guys, you got to make sure that this is the answer by seeing if you can simplify the original equation to its bare bones and then plugging in the evaluated x value and see what you get. So you got to take it a step further and see if you can manipulate this equation to make it in a form that you'll get a real number first. If you still get 0 over 0, then you write does not exist. So do not write this first thing, you will get a 0 on the question. Even if the actual answer is does not exist, you're still going to get a 0 because you didn't further manipulate this equation to see what would happen if you plugged in the x value later on. So let's move forward with the problem. In math in general, when there's a root in the numerator, it's bad. We got to get rid of it. So we multiply by the complex conjugate to get rid of that bracket, that square root symbol. So let's take this equation. Again, we're omitting to write the limit expression because it saves time. Over, I forgot to plug back in the x here. Okay, 2x plus 3 minus 3 over x minus 3 multiplied by the complex conjugate. Complex conjugate is same thing as multiplying by 1 over 1, except so we got to put the numerator and denominator the same, and you reverse the sign of the third term, the extra number sitting outside the root. Alright, to save time, I'm not going to evaluate this. I encourage you guys to evaluate these algebraic expressions, because algebra is the foundation of the next couple of math courses you will take: Cal 2, Cal 3, differential equations, partial differential equations, and even mechanical engineering. When you're taking control systems and control systems 2, you're going to use the heck out of algebra, especially in Laplace transforms. It's going to kill you if you don't know how to do algebra properly without making mistakes. So practice, 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 guys. So evaluating this expression, we end up getting 2 over root 2x plus 3 plus 3. And now if we decide to, well, we have no choice, but take the limit as x approaches 3 of this equation, 2 over root 2x plus 3 plus 3, we get 2 over 6 equals 1 over 3. See guys, it was not 0 over 0. This is wrong. We actually got a real number over here. So that's the answer to our question. Let's move on to question B. Question B says the limit of x approaches 0 of x minus 4 over 4 minus x squared. 4x minus x squared. So the limit as x approaches 0, x minus 4 over 4x minus x squared. Alright, I'm going to give you a chance to solve this on your own. At least, if you're not going to solve it, at least manipulate the expression to see what you can get and to see if you end up getting what I got. So I'll let you pause the video right now. And other than that, I'm going to continue. So the first step, as always, is to plug in your 0. X approaching 0, you plug it into the equation. You end up getting, 0 minus 4 over 0 minus 0. It's negative 4 over 0. Yes, you might have remembered that this is similar. This is usually negative infinity as the answer, but no. Again, like in the previous problem, you still gotta further manipulate this equation to see if this is actually the correct answer. You can work with this equation. You can break it down. You can put it to its bare bones, and then evaluate it and see if you get what answer you get. So take note if you're writing this down. Not yet. Let's move on. How can we, I'm going to drop the limit for now, the limit expression, and we're going to evaluate this equation. How can we manipulate this equation? It looks like it's a factorable equation. You see the denominator is easily factorable. X minus 4, pull out a x in the denominator, 4 minus x. You see that the numerator and denominator have a common factor, albeit by a little negative sign. So you're going to switch these two over here and multiply by negative to get the same expression on the top and the bottom. So it becomes a negative here, x minus 4. Crossing out. So what happens in types of problems in calculus, you're usually going to end up canceling out common terms and getting a very simple expression. So canceling that out, we get negative 1 over x. And now we have the bare bones. So now we can take the limit as x approaches 0 of negative 1 over x. So plugging in 0 over here, we get a similar form as this one here, negative 1 over 0, except this time we're in the bare bones already. So there's no other solution but negative infinity. There you go. All right. The next problem is stating that the limit as x approaches infinity of x cubed minus x plus 3 over x to the power 4 minus 2x squared minus 2. They're always going to throw in an infinity one. They have no choice because that's a real one to see if you understand the concepts. So it's the limit as x approaches infinity of x cubed minus x plus 3 over x 4 minus 2x squared plus 2. Whenever you're looking at expressions as x approaches infinity, there's a specific method you have to use, and it's comparing the exponents of the numerator, the highest exponents of the numerator and denominator. So we'll call this n for numerator, d for denominator. You look at the exponents of each, the highest exponents in each part of the fraction. So in the numerator, the highest exponent is 3 from the x cubed, and in the denominator the highest exponent is 4. And the rules are that if the denominator's exponent is greater than the numerator's exponent, you end up getting a limit equal to 0. If d is less than the numerator, then you get the limit is positive infinity. And if d and n are the same, the limit equals 1. So looking at this, we have 3 and 4, so d is greater than 4, so the limit as x approaches infinity equals 0. For some reason, if you forget these rules, or you just don't think of it and you go straight to manipulating the equation, you could try to plug in infinity, but you get a mess. You'll get infinity minus infinity plus 3 over infinity minus infinity plus 2, and you can't really tell something with that. You could say the answer is infinity. You'll probably say the answer is infinity. How can you tell that the answer is 0? You'll never know, really. You're going to have to manipulate this equation before you can jump to any conclusions. So to manipulate polynomials like this, when you get them, especially when you get them with x approaching infinity, I encourage you to use this. This is number 1. You have to use this. But if you don't, you can always factor, and that will be done by pulling out x4. If you pull out x4 here, you'll see what happens. Look. So you pull out x4 from the numerator and denominator, you end up getting 1 minus 2 over x squared minus 2 over x4. And the numerator, you can also pull out x4. You'll just have to adjust the factors inside. So 1 over x minus 1 over x cubed plus 3 over x4. And you can see, guys, if you multiply all this out, you'll get back this original equation. But so the reason it's important to have it in this form when you're evaluating at infinity is if you were to plug in infinity right now, you'll see first of all, you can cross these out because they cancel. But if you were to plug in infinity into here, 1 over infinity, so that's equal to 1 over a very large number, this term will go to 0, this term here will go to 0, this term here will go to 0, this one will stay 1, this will go to 0, this will go to 0. So you end up getting 0 over 1 equals 0. So you get the same conclusion as using the exponential comparison method. But again, guys, use that method, use the first method, because it's the best one. Sometimes you will not get it that easy where you just directly compare. Sometimes you're still gonna have to do you're gonna have to factor a little bit. An x might be outside of this, and you'll have x squared minus 1 plus 3 over x. You'll be tempted to take the 2 as the exponent for the numerator, but no, you gotta multiply this out. Just don't get tricked like that, okay? Alright guys, before we start question 2, I just want to point out that if you feel comfortable with any of these questions and you want to skip to a specific one, I will put the times of the start of each question and their labels in the description below, so you can directly go to a topic that you're struggling with. Also, don't forget to leave a like and subscribe. I will be posting many types of final exams and maybe help you out through your journey in university. And share these videos because I want everyone to succeed and I want them to have as much help as possible. So question 2 is use the definition of continuity to determine whether f of x is continuous at x equals -2. Alright, so in a nutshell, they're asking, we got a graph here. We don't have to graph for this problem, but it's easy to understand if I point it out. So if we're trying to find at -2 if the graph continues at -2 or if there's a break over here. So a break could look something like, so we got a graph coming in, a line coming in from the left that stops at -2 and it continues above over here. This is a break. If it's coming like that and it's continuing here, So if you were to take the limit as x approaches -2 from the left, you would have a value here, and if you take it from the right, actually this is not a good example. It's mostly of this form it's going to look like when it's not breaking, because if you take the limit as x approaches 2 from the left, -2, you'll get a y value, an f of x value of this, and if you take it from the right, you'll get a value over here which is different from this value. So that means that there's a break. So if I can somehow prove this concept with this piecewise function, we have an answer to whether it's continuous or not at x equals -2. So using this over here is the definition of the continuity, but I'll write it in an equation because you're probably going to have to write the equation down just to prove that you're using continuity. So let me just say that. All right. So piecewise function just means that you have a function for x less than -2, which means that you're approaching from the left, basically, like I said over here. And the third function here, x is greater than -2, which is basically you're going to be approaching from the right. You're going to be approaching the function at the value x -2 from the right. So if we can take f of x in this case is all those three over there, if we can evaluate the limit on each side and see if it matches with f of a, because f of a, f of -2, a equals -2, f of a equals -3, right? So if this limit as x approaches a of f of x on both sides equals -3, then we have continuity. So let's evaluate the limit of f of x as x approaches -2. And in order to do that, we have to take one of these functions. So let's start with the top one, which is approaching from the left, and see if it equals -3. If it doesn't, then we have a break. So see, we plug it in the numerator, we get -7 and over 0. No, it does not approach -3. What actually happens is that you got -2 here. As it's approaching -2, it just ends up going to -infinity. It never has a defined value of -3. Now evaluating the other one. Well, we can conclude right here that the answer is it's not continuous at -2 because coming from the left side, we do not have -3. Let's just evaluate 2x plus 1. Sorry, x approaches -2 of 2x plus 1. We do in fact get -3, so it is, this continuity rule does apply, but only if you're coming from the right and you're using the third equation. But since it does not work for the first equation, we have not continuous. Hope you understand. I tried to make it as clear as possible. If you have any other questions, don't be shy to leave a comment down below. I will further clarify if you need help. Alright, so the next problem is asking us to use the limit definition of the derivative to find the derivative of f of x equals x squared minus x plus 7. Alright, do not evaluate a problem using regular differentiation rules. You have to use the limit definition of the derivative, the old school method, I guess. This is the formula, and you got to memorize it. It's pretty easy to memorize, just photographic memory. Stare at it for like 2 minutes. What it means is that the derivative of our function is equal to the limit as the change in h approaches 0 of our function, and every x value you add a h to it, minus our function itself over h. So this term here, you take every x in our original function and you add a h to it. That's all it means. So let's do exactly that. So the derivative of our function is the limit as h approaches 0 of, so we're adding h to x squared. No, that's actually wrong. You add the h to the x and then you square everything. Don't make that mistake. Minus x plus h, bracket that up, plus 7. And then you take all that and you subtract it by the original function itself. All over, no, there's no over. Yeah, h. Alright, so next step is pretty much gotta expand everything. So we're going to take this first bracket and multiply it out, and then get rid of this bracket and multiply that negative in. So doing that, we get this mess over here, x squared plus 2xh plus h squared minus x minus h plus 7 minus squared plus x minus 7. And this is always going to be this big, and you're going to see that a lot of stuff gets cancelled out. This x gets cancelled out with that x. This 7 cancels out with that 7. Leaving us with all this x squared here gets cancelled as well. So we get left with h squared plus 2xh minus h all over h. And let's go down a bit. You can see from the numerator we can factor out a h. I'll just not write the f prime of x. Factoring out the h, all over h. This step over here is important. You got to get a h out from the numerator so you can get rid of it with the bottom. Because if you were to plug in 0 before you cancel out those h's, you'll just get the limit is 0 over 0, which we don't want. Remember I said that we have to continue simplifying if you're going to get 0 over 0. So now we can actually evaluate this expression and make h go to 0, and we get our answer of 2x minus 1. You can't do anything with this x. Usually when you're using the limit definition of the derivative, you end up getting expression in terms of x. So that is our answer. Who comes up with these equations? Who thought of the limit definition of the derivative? Look at that huge formula. Who thought of that thing? I know I can't think of that. I'm not that smart enough. So I'll see you. Let's do the next question.